Okay, so in this video I want to have a preliminary look at sketching graphs of polynomials. Now I'm just going to have a look at a few definitions and generally what you do when you want to sketch polynomials. So first of all, I'm just going to have a look at some definitions that you'll need to know, some terms that that are going to be used when dealing with polynomials and sketching them. So let's just look at the definition of the word polynomial first of all. Now, a polynomial will look like this here. It's a function, we'll call it f here, f of x, and it will be some number times x to the power of some number plus another number times x to the power of another number plus, and so on and so on. You'll have a number times x squared, a number times x power of 1, and then some number at the end here. Now, all the powers that we're going to look at here will all be non-negative. So all of these powers here must be positive, first of all. And all the a's here, all the numbers in front of the x's, x to the power of n and so on, all of these a's here, all of the coefficients must be constants. So they must be numbers like 3 and 5 and 10 and so on. Okay, so for example, 3x squared plus 5x plus 3 is equal to f of x. This is a polynomial. Why is it polynomial? Because you've got your powers here. You've got an x to the power of 2 and x to the power of 1 here. So the powers are not negative. They're positive numbers, 2 and 1. And the a's are constant. So the numbers in front of the x squared and the x and this 3 here, they're constants. 3, 5, 3, they're constants. They're not variables. Now this one here is not a polynomial. Let's have a look at why it might not be a polynomial. Well, you've got you've got your a's here as a 4, you've got a 7, and you've got a minus 4 here. Well, they're constants, so that's fine. We've got a 4, a 7, and a minus 4, all constants. What about the powers then? Well, you've got x to the power of 2, and which is fine. 2 is it's a non-negative whole number. Here you've got the square root of x. Now the square root of x is x to the power of a half. So x to the power of a half here, half is not a whole number, therefore the power is not a non-negative whole number. So this here is not a polynomial. Okay, so that's your polynomial. Let's have a look at some other definitions here. We have roots. Roots are zeros, as they're sometimes called. They're the values of x for which f of x is 0. So in other words, if you've got some kind of polynomial and you draw it, you have your xy axis and it looks like this, for example. This is the graph of a cubic polynomial. F of x is 0, or y is equal to 0. Y is equal to 0. So where on this graph is y equal to 0? Well, y will be equal to 0 on this graph here, here, and here. In other words, if you were to write down the coordinates of those 3 points, it'll be some x value and then your y value will be 0. Some x value and your y value will be 0. And the same here, some x value and your y value will be 0. So there are only 3 points on this particular curve here where y is 0. Here, here, and here. So it's the value of x. Whatever that x value there is, that's a root. Whatever that x value there is, that's a root. Whatever x value that is, that's a root of this particular function here. So it's where your curve cuts the x-axis, or where y is equal to 0. It's the x value for which y will be equal to 0. So that's a root. The degree is the highest power within the polynomial. So for example, if you have something like 3x to the power of 4 plus 2x squared minus 5x plus 3 is equal to our function f of x here. The degree of this polynomial, the degree of this function here is 4, the highest power of x. The leading coefficient is the coefficient of the term with the highest power. So if you look at this again here, the term with the highest power here is this term here. This term here has the highest power. The leading coefficient is 3. Okay. And that's, let's see, do we have any more here? Oh yeah, multiplicity. We're going to talk about multiplicity here. So multiplicity is a polynomial has a factor or a root that occurs more than once. So if you take a particular polynomial, so for example, f of x is equal to, let's say, x to the power of 5 minus 2x to the power of 4 minus 23x squared plus 6, let's see, x to the power of 5 minus 2x to the power of 4 minus 23 x to the power of, we'll say x to the power of 3 here, plus 64x squared plus 4x minus 80. Now, if you factorize this, you'll find that one of the roots, or one of the factors rather, is x minus 2. And another factor is x minus 2. So that's just x minus 2 squared. So this particular factor here occurs twice. So this, you know, x is equal to 2, in other words, x will be equal to 2. This is our factor here, so x is equal to 2 is a root of this particular. So in other words, if I put 2 into this this function here instead of x, I'll get 0. So 2 is a root. In other words, one of the places where that particular function cuts the x-axis is 2, 0. But it occurs twice. So it's what's called a repeated root, repeated factor. X is equal to 2 is a root that has multiplicity 2. So x is equal to 2 is a root and it has multiplicity of 2. Okay, so let's just move on a little bit and we'll have a look at what these curves will look like under various conditions. So let's have a look. Say we have a polynomial, a particular polynomial, and it has a factor, a particular factor of x minus m, and we'll say it's to the power of n. So in other words, this particular factor here occurs n times. So for example, it could be, I don't know, x minus 3, and it might occur 4 times, for example. So you would have roots of x is equal to 3 occurring 4 times, having multiplicity. X is equal to 3 would be a root, and that has multiplicity 4. So anyway, our factor is x minus m, and our it occurs n times. So if this n here is an even number, then what happens to the actual curve is that, you know, it'll look something maybe like this. It'll come down here, maybe it'll touch the graph and it'll go back down again. Whoops, let me just redo that bit. It'll come down here again and maybe head off in that direction again. So if x minus m to the power of n is a factor, and if n here, if this n here, n is even, if it's an even number, if it's 2, 4, 6, 8, 10, then the graph of the polynomial touches the x-axis at m here. X is equal to, so x will be equal to m, that's our root. So it'll touch it here at m, x is equal to m. It'll touch the x-axis, but it won't cross the x-axis, it'll come back down again. So that's when m here is even. Okay, now if on the other hand n here was odd, so for example, if we have, I don't know, let's say x minus 3 again, and let's say it's to the power of 3. So again here x is equal to 3 as a root, okay, and it has multiplicity of 3 this time, but this time our n is an odd number, it's 3. what happens here is that, let's say we'll draw it again here quickly. Let's say it'll come down like this, for example. It'll come up here again, it'll kind of flatten out and maybe go up like that. So this time, because this value here, this n value here, this power here of this particular factor is odd, the graph will cross the x-axis, but it'll kind of flatten out before it goes off in the same direction here. So it'll kind of flatten out here. And our root is 3, so this value here will be 3, or if it's x minus m, this value here will be m again. Okay, so let's have a look at some of the rules around sketching these polynomials. Now, if the polynomial itself has, let's say, even degree, so we're going to look at even degree, okay? The polynomial has even degree. So for example, it would look like, say, I don't know, 3x to the power of 4 plus 2x to the power of 3 plus, let's say, x squared minus 5, something like that. So this has even degree. It has a degree of 4. The highest power of x is 4. So that has even degree. Then the arms of the graph will both point up or point down. So in other words, you'll start like this. It will have various shapes in between, and the arm will finish off going in the same direction as this arm here. Or it can start like this, and then it will have various shapes in between, and it will go back down at this side. So it will, the arms of the graph will either point upwards or point downwards. So that's if it's even degree. If the leading coefficient is positive, then the right arm will point up. So for example, let's see. No, actually what we'll do first is we'll just have a look at if it was odd degree. We'll look at that first, okay? So let's have a look at that. Odd degree. We'll have a look at that. So if it's an even degree, the arms will point up or they will point down. If it's an odd degree, then one arm will point up and one arm will point down. So it will look something like this. Let's say we'll start here, and it'll have various shapes in between, and then the arm will go up that direction. Or if you start like this, it will look like that at the end. So one arm will point up, one arm will point down, or one arm will point down, one arm will point up. So if the degree of your function is odd, if this number here is odd, if it's a 3, a 5, a 7, and so on, your graph will look something like this in terms of its arms. Okay, so how do you know which arm will point up, which arm will point down? So let's have a look at that. Okay, so if the leading coefficient is positive, okay, the leading coefficient, if the leading coefficient is positive, the leading coefficient is positive. Now, so the leading coefficient is positive, then the right arm points up. So for example, if you've got a, let's say, 3x cubed plus 2x squared minus 5x plus 3, that's our function, something like that. We can see here that it has odd degree, which means that one arm will point up and one arm will point down. But our leading coefficient here is positive, then the right arm points up. So that will look something like this. The right arm will point up, and you'll end up going down that way. The right arm will point up, the left arm will point down. Okay, So if the leading coefficient is negative, so in this case we've got the leading coefficient is negative, so if our leading coefficient is negative, so for example, if we have minus 3x cubed plus 2x squared minus 4x plus 7, if that's our function f of x, then what happens is the right arm points down and the left arm points up. So in this particular case we would end up with something like this. Okay, so our leading coefficient is negative. It has degree 3. This is our degree here of 3, and the leading coefficient, which is the number in front of this particular variable here, x, is minus. It's negative. So our right arm points down and the left arm will point up. That's as much as I'm going to do on these particular rules. What I'll do in another video is maybe do an example of a particular example of how you would go about sketching these different polynomials.